BUNZL and the Compost Manufacturing Alliance are bringing the supply chain to compost manufacture piles to create the best network for compostable product engagement in the U.S., sharing a common vision to connect manufacturers of compostable products to the compost piles they were intended for. BUNZL and CMA, North America's only compost manufacturer-driven third-party certifier of compostables, provides an expansive network that matches product distribution centers to the growing network of CMA processing facilities accepting compostables. Composting food scraps, yard trimmings, and leaves creates the perfect recipe to make Earth's most important soil amendment, compost. Almost 40% of the garbage generated in the U.S. contains valuable, nutrient-rich materials that can be converted to healthy soils and natural mulches. Once applied to our environment, compost contains slow-release nutrients, microbial activity, and structure to help grow, replenish urban soils, grow healthy plants, keep our waterways clean, and help keep carbon in the soil to help mitigate factors that lead to climate change. Composting can be done in our own backyards, while more and more cities, counties, and states are offering this service through facilities like St. Louis Composting, a Compost Manufacturing Alliance member since 2016. Today, we will follow the path of food scraps and yard trimmings once they arrive at a composting facility, and why the work commercial and municipal compost facilities do is so important to our environment, economy, and food service operators serviced by BUNZL in this collaborative partnership with CMA's growing network of compost manufacturers. Feedstock sources. Commercial and municipal compost facility owners and operators follow several stages in their process to produce good, quality compost. The first is to ensure they have good, steady, and clean source of materials. These materials can be collected from many different sources: landscape projects, homeowners' yards and kitchens, the office lunchroom, schools, food processing plants, commercial kitchens, and even large stadiums. Feedstock grinding, mixing, and pile hydration. Once collected, valuable materials called feedstocks are offloaded at the compost facility where they are ground and mixed. The grinding and mixing process helps compost manufacturers create a reliable recipe to ensure the compost produced at the end of the process is consistent, microbially active, and contains just the right blend of browns, carbon-bearing materials like wood, and greens, nitrogen-bearing materials like grass and food scraps. The grinding process takes tree trunks, limbs, food scraps, and properly sizes the feedstocks for optimal processing in the compost facility. Most composters add resident microbes to the mix from the oversized wood chunks that have already been through the process and screened out. CMA facilities also pull samples of the feedstock before they start the composting cycle to ensure they are consistently hitting the recipe targets for carbon, nitrogen, moisture, bulk density, and other characteristics. There are a variety of composting processes within the CMA network, while windrow is the most common type and the one used at this St. Louis composting facility. Once material is ground and mixed, the prepared feedstock may be hydrated to hit the proper moisture level before loading the material onto a windrow. Once in place, time, turning, and Mother Nature work in harmony to create the best conditions for the material to biodegrade and convert from a feedstock to a finished product. Loading into windrows and pile turning. Once compost feedstocks are placed into rows, they are monitored for temperature and turned so the piles are enriched with oxygen at regular intervals. The oxygen helps promote optimal microbial activity to break down the feedstock into compost. Piles heat up between 130 and 160 degrees when turned and aerated, and these temperatures will rise through 3 stages. The windrow process can range from 90 to 120 days in duration. While temperatures ramp up and down within 3 different stages: the mesophilic or moderate temperature stage, the thermophilic or high temperature phase, and then the curing phase, where temperatures stabilize at the end of the process. Once the process is over, a sample is taken of the finished product and tested for various characteristics. All CMA facilities make products that meet the U.S. Composting Council's Seal of Testing Assurance, or STA program. Lab reports on the finished compost are submitted for review under STA so that the compost quality can be confirmed to be what the facility targeted in their feedstock recipe. Screening, overs, rejects, and CMA field testing. Once the process windrows has completed its cycle, contaminants that did not break down in the process must be screened out, so the final product is clean, aesthetically pleasing, and consistent. Contamination comes from many sources, with the highest amounts brought in from food scraps. Plastic bags, produce containers, produce stickers, yogurt cups, lids, and a variety of non-compostable materials must be removed and can create significant costs to the composter. In addition to these items, products designed to be compostable in a lab may not break down adequately in real-world composting systems and end up getting screened out in the process and shipped to the landfill. That is why CMA works with facilities like St. Louis Composting to conduct real-world field testing, ensuring that products that are sold as compostable are compostable and work to the satisfaction of the receiving facility. This remains a growing issue with facilities that are hesitant to accept compostables that have not been proven to work in their system. When products don't break down, composters can't accept them, and customers procuring compostables food service items are really just giving these products a long and expensive ride to the landfill at the composter's expense. This model is not sustainable, so BUNZL and CMA are working in partnership to collaborate with brands, packaging developers, school systems, cities, haulers, and composters across the U.S. to create a network of facilities that work together to incorporate both laboratory and field standards and ensure compost facilities have the system for accepting more and more compostables that is customized to their operations, capabilities, and budgets. At the completion of screening, most facilities stage the compost for additional curing, where, like a fine wine, the compost continues to gradually break down and darken into a rich, dark, nutrient, microbially active mulch or soil amendment as it ages. Sale product: talking to customers and loading trucks. Once compost has been screened and aged, it can be used for a variety of applications. As a gardening amendment, compost helps promote water retention while it feeds the soil's natural nutrients and beneficial microbes that create an optimal and natural productive yield in yards, community gardens, and on rural and urban farms. Compost is excellent when applied for erosion control on highway projects, stream banks, and on slopes. Compost is also the base for many soil blends like topsoil, vegetable garden mixes, and engineered soils used on large construction projects. Compost can be mixed with sand and sandy loam to create these blends and is also mixed for bagged mulches and potting soils. CMA facilities provide this compost all over the U.S., improving the climate, the environment, and the local community's economic and sustainability footprint. CMA members and commercial and municipal composters across the U.S. must work in collaboration within the supply chain to ensure the system of employing compostable products includes the receiver of the materials and protects the investment of the cities, hauling companies, and the valuable composting operators. That is CMA's purpose and mission. And as a BUNZL partner, this program connects the supply chain to the piles through the strength of our collective networks.